Hello, welcome to the video notes for lesson 6-2. And this lesson is about solving systems of linear equations by graphing. And this is day 1, so we're going to be doing this over a couple lessons. This begins on page 7 in your binder. Remember, it's the new page 7 because we had two parts to this. So the learning target for this, I can solve a system of linear equations by graphing. So remember, in the previous lesson, we looked at solutions and tested to see if they were true, if they worked. And when the point worked for both equations, then we knew that it was a solution. When we're graphing, it's similar, and we can always test it by once we get the answer, seeing if it really works. So there is a check, and that's the nice part about this. All right, so our example on this page is, what is the solution of the system by graphing the equation? So we've got two equations, y equals 2x and y equals x plus 4. So graph 1. Let me pick the right color here. I'm going to use red for this one. I'm going to do the y equals 2x. So what do I know about this? Well, first of all, there's nothing after it, so that means the y-intercept, b, is 0. So b equals 0, which means it's the point 0, 0. So there's a point there. Then the change in y over the change in x, that's m, and it's 2. So that's this right here. But remember, 2 is 2 over 1. So change in y is 2, change in x is 1. So I go up 2 over 1, put a dot, up 2 over 1, put a dot, up 2 over 1. Remember, this could also be negative 2 over negative 1. That's another way to get a positive slope, is a double negative. So down 2, left 1, down 2, left 1. All right, and we've got enough dots, so I can go ahead and plot this, or I'm sorry, connect the dots with my nice straight line, and there we go. So there's one line. Graph 2 is going to be the other equation. So this one was 2, the other one was 1. Graph 2 is y equals x plus 4. So again, so first thing I have to find is, let's start with b, which is 4. So I know that is the y-intercept, and it's 0, 4. So I'll plot that point, and that's right here. Next thing is my slope, so change in y over change in x. Now a lot of students have had trouble remembering that when there's no number in front of x, that's a 1, or 1 over 1. So I'm going to use that slope, so up 1 over 1. Remember, a positive 1 over 1 is the same as a negative 1 over 1, and that looks like that. So I now connect these points with a straight line. And it's kind of hard to tell because when I made my line here, I didn't make it far enough. So that's why it's always important to extend it through the whole graph. But the point that we have, that is the point of intersection, is right here at the point 4, 8. So the solution that we have for this is 4, 8. So check. How do we check it? Well, it's real simple. We do ESS, just like we did in the last lesson, for both equations using the points 4 and 8. Remember, 4 is our x value, 8 is our y value. So the first equation, remember, was y equals 2x. I substitute 8 in for y. I substitute 4 in for x. 8 equals 8, and that one checks. The second equation was y equals x plus 4. So I substitute 8 in for y, 4 in for x. 4 plus 4 is 8. 8 equals 8, and it checks. Alright, so that's how we solve graphically. We look for the point of intersection. It's pretty easy to see, so this is a visual skill. Remember, we did see an example when we did this in math where we had parallel lines. So if you see parallel lines, if it's clear that they're not going to connect, then there would be no solution. Otherwise, they will intersect and you will get a point of intersection. Alright, so over on page 8 we have a couple more examples. We'll go through this kind of quickly here. So we've got our two equations. So y equals x minus 3. Remember, we're going to pretend there's a 1 there. So my slope, change in y, over change in x, is 1 over 1, or negative 1 over 1. My b is negative 3. So that means my point is 0, negative 3. So one line has a point at 0, negative 3, and it goes up 1 over 1. Up 1 over 1. Now, actually with this, it's really important that when you connect these, that you make sure your line, so I don't have a ruler on here, I'm just using my straight line tool. Ruler is actually better because it will cover more of the graph. Your line should go across as much of the graph as possible so that you can see. And actually we're going to start also labeling our lines in the graph. So this is y equals x plus 3. The other line is y equals 1/7 x plus 3. So again, my b is 3, which means it's 0, 3. So I put a point there. And my slope, change in y over change in x, is 1/7. So up 1 over 7. So we've got a point of intersection there. Or down and to the left 7. So point there. And now I'm going to connect them with my straight line tool. You'll use a ruler. And here is our answer. It is the point 7, 4. So solution 7, 4. Alright, so now we do the check. So I've got one equation, so I'm going to do ESS for both of these. One is y, oh, and don't forget to label your equation on the graph. So this one is the y equals 1 over 7x plus 3. Alright, so y equals x minus 3. Remember your x and y values. So y is 4, x is 7. 7 minus 3 is 4, so 4 equals 4. That is true. ESS for the other one. So y equals 1 over 7x plus 3. So plug in 4, plug in 7. 1/7 times 7 is 1. 1 plus 3 is 4. 4 equals 4. And it checks. Alright, so remember, we're looking for the point of intersection. That's the solution. We're using the slope and the y-intercept to help us find points. The video is starting to get a little long, so I'm going to help you set up the next problem, and then I'm going to let you finish it. We're going to write solution. When you find the solution, when you find the point of intersection, you're going to put it here. And don't forget to test it. Alright, so we've got y equals 3x plus 2. So my y-intercept is 2. So if b equals 2, that means it's the point 0, 2. My slope is 3, change in y, over change in x, is 3 over 1. Or, remember, negative 3 over negative 1. So you're going to use this to plot points. The other one is b equals negative 8, which is the point 0, negative 8. Change in y over change in x is negative 2 over 1, or 2 over negative 1. So that's how you're going to plot your other points. See if you can find the point of intersection and do the check. If at least one person can find the answer and show all the work. Actually, I got an idea. I'm going to check your work really quick, see who finds the point of intersection and shows the check for both equations, and for every person that does, that'll be a point on your scoreboard. So hopefully a lot of you are doing this homework and writing all that information down. Good luck, and we will see you in math.